Welcome to my channel Mathmagic. Me, Provish Sarkar, teach you how to solve different types of mathematical problem to more easier and easiest way. Okay. So today we will start principle of mathematical induction, class 11 mathematics chapter. Okay. Let's start. Principle of mathematical induction. Okay. So first of all, you see what is mathematical statement. Okay. Statement involving mathematical relation is called a mathematical statement. I repeat, a statement involving mathematical relation is called a mathematical statement. Okay. Now give some example. Example number 1. X minus 2 is a factor of x square minus 3x plus 2. This is a mathematical statement. Okay, give another example. Sum of first n natural number is n into n plus 1 divided by 2. This is also a mathematical statement. But Calcutta is a capital of West Bengal. This is not a mathematical statement. So students, all of you clear what is mathematical statement? Now come to the point, the principle of mathematical statement. Okay, so to understand the basic principle of mathematical induction, we give an example and discuss with this example. Suppose a set of thin rectangular tiles. See, everyone see here. Suppose a thin of so many rectangular tiles are arranged one by one in a queue. Okay, in this way. 1, 2, 3, 4, all are the thin rectangular plate or tiles. So many. Okay, 1, 2, 3, 4, dot, dot, dot. That means so many. Suppose we push the first tile in this direction. So what happened? First tile falls, then second tile falls, then third tile falls, then fourth tile falls, and so on. Now check. The all tiles are fall or not? Check. Okay, take first one. This is false. Yes, look at the first one. This is false. Yes, false. That means first tile is false. Now take any one of this series, any one tile, choose any one tiles of this series. Suppose kth tile, here is kth tile. Okay, okay, k is any natural number. So suppose kth tile, check this tile is false. Yes, false. Okay, now very next tile, see the very next tile, that means k plus 1 tile. So this tile is false. Yes, false. That means all of the tiles false in this series. Okay, now see carefully, when the first tile is pushed in the indicated direction, all the tiles will fall. Now look any of this tile, it is fall, then look its next tile, it is fall, then we sure all the tiles are fall. Okay, so in this event that any tile falls, its successor necessarily falls. Okay, this is the underlying principle of mathematical induction. That means this example is understand the principle of mathematical induction. Now suppose there is a given statement Pn. Okay, we take a given statement that is Pn. This is a given statement, any statement relation to mathematics. Okay, so suppose the statement Pn involving the natural number n. N means natural number. Number 1. Okay, the statement is true for n equal to 1. Now number 1, the statement is true for n equal to 1. So P1 is true. Okay, that means first tile is false here in this figure, in this drawing. Okay, so put n equal to 1 in this mathematical statement. So we get P1 is true. Okay, if match it, that means LHS equal to RHS, then we say that P1 is true. Now the second one, if the statement is true, if the P1 is true, then we assume that, second statement, assume that n equal to k. Put n is equal to k and pk is true. Okay, now the final stage or final step, that is number 3, that put n equal to k plus 1. This is the final and third step. Okay, important step. So if we prove that in LHS we put instead of n k plus 1. If the equation satisfies the RHS, that means this statement is true for all the values of n. Clear? Now come to the example, and all of you clear? See, in the first example, prove that by a mathematical induction. Prove by mathematical induction that question number 1 plus 5 plus 9 plus dot 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 plus last term is 4n minus 3 is equal to, the answer is n into 2n minus 1. n into 2n minus 1. All of you clear? This is the mathematical statement. 1 plus 5 plus 9 dot 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 up to the last term is 4n minus 3. The answer is n into 2n minus 1. Clear? Okay. Now this is the mathematical statement required to prove this mathematical statement is true or false. This is true or false by using the principle of mathematical induction. First step, put n equal to 1. Okay, this is Pn. This is Pn. Clear? So put n equal to 1 in LHS. Left hand side 1. Okay, first term is 1, so LHS 1. Then RHS n means 1. 1 into 2 into 1 minus 1. That is 2 on the 2 minus 1. That is 1. LHS equal to RHS. So clearly say that P1 is true. Okay, first step completed. Now second step. We assume Pk is true. So we assume put Pk. Instead of n we put k. So 1 plus 5 plus 9 plus dot 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 plus 4k minus 3 is equal to k into 2k minus 1. Clear? Okay. We assume that this statement, instead of n we put k. This statement is true. Now required to prove p n k plus 1 is also true. This is the final step. P k plus 1 is also true. Now check. P k plus 1 is equal to, instead of k we put k plus 1. Okay, so 1 plus 5 plus 9 plus dot 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 plus 4k minus 3. This is the last one, and after that put k plus 1. That means 4k, instead of k put k plus 1. That is 4k plus 4. 4k plus 4 minus 3. Got it? So instead of k we put k plus 1. Only write the LHS. On using this LHS, we put k, instead of n we put k plus 1. We get the result on RHS. Okay, if the result LHS equal to RHS match, then we say that by mathematical induction this statement is true. Now see how to solve it. So see, 1 plus 5 plus 9 plus dot 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 4k minus 3. Up to this the result is k into 2k minus 1. That is already given. Okay, so directly write k into 2k minus 1 plus 4k plus 1. Okay, now multiply this k. So 2k square minus k plus 4k plus 1. So finally we get 2k square plus 3k plus 1. Clear? Now using middle term factorization. Okay, we get 2k square plus 2k plus k plus 1. So take 2k as common from the first 2. So we get k plus 1. And then take 1 as common. So k plus 1. So their result is k plus 1 and 2k plus 1. Okay, now arrange this result in this format, but in k plus 1 form. Okay, see, here n means k plus 1. So k plus 1, and here is 2n minus 1. That is 2 into k plus 1 minus 1. Okay, that means the result is same as shown in the sum. Okay, so it is clear that LHS equal to RHS. We get RHS. So by using mathematical induction, prove it. This statement is true. Clear? Now come to the second example. Another example. See, everyone clear? Now second example. See carefully. Second example. Second one is example number 2. 1 square plus 2 square plus 3 square plus dot 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 plus n square is equal to n into n plus 1 into 2n plus 1 divided by 6. Okay, this statement is Pn. Okay, we take Pn equal to this statement. That means sum of the squares of all natural number is n into n plus 1 into 2n plus 1 divided by 6. Okay, required to prove by using mathematical induction this statement is true. Okay, n is any natural number. That means n belongs to capital N. N belongs to capital N. Any natural number. Clear? Now see how to prove. Same, first put n equal to 1. So n equal to 1. Put n equal to 1. So we get LHS 1 square, that is 1, RHS 1 into 1 plus 1 into 2 plus 1 divided by 6. Okay, so 1 plus 1 2, 2 plus 1 3 divided by 6. 3 to the 6 by 6, that is 1. Clear everyone? So LHS equal to RHS. So we can write P1 is true. Okay, now second step, we assume that Pk is true. That means Pk equal to 1 square plus 2 square plus 3 square plus dot 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 plus n square, sorry, k square equal to k into k plus 1 into 2k plus 1 divided by 6. We assume that Pk is true. So directly we write, instead of n, we put k. Now the final step, okay, that is k plus 1 is also true. So therefore Pk plus 1. So we put the value k plus 1 on the LHS, remember it. So 1 square plus 2 square plus 3 square plus dot 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 plus k square, and next stage is k plus 1 whole square. Okay, instead of k we put k plus 1, previous term k square. Clear everyone? So now from this sequence or this series must come this. Okay, this is the answer. Now see how to solve this. 1 square plus 2 square plus 3 square dot 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 k square up to this. The result is this one. So directly we write k into k plus 1 into 2k plus 1 divided by 6 plus k plus 1 whole square. Okay, now take k plus 1 as common from the whole. So we take k plus 1 as common. So remaining is k into, directly multiply 2k square plus k. 2k square plus k, and the LCM is 6. So here is 6k plus 6. Clear? Now k plus 1 into 2k square plus 7k plus 6 divided by 6. Clear or not? Now do the middle term factorization in the numerator. So here is 6 to the 12. From 12 we get 7. How to? 3 for the 12, 4 plus 3. So you write k plus 1 into 2k square plus 4k plus 3k plus 6 divided by 6. Clear? So finally we get k plus 1 into 2k plus 3, and here is k plus 2 whole divided by 6. Clear? Now arrange the result in this format. Now see how to arrange it. See carefully. Okay, the final line is k, n means k plus 1. Okay, now k plus 2 we write k plus 1 plus 1, that is n plus 1, k plus 1 plus 1, arrange it. And then 2n plus 1, that means 2 into n means k plus 1, then plus 1, then we get 2k plus 2 plus 1, that is 2k plus 3, okay, divided by 6. That means the result is matched on the RHS, okay, as far as RHS. So it is clear that by using principle of mathematical induction, this statement is true. Okay, this must write, everyone must write this line on the last. By using principle of mathematical induction, this statement is true. Okay, now everyone see more and more video I upload. So everyone subscribe my channel. Thank you.